Okay, AP Statistics, we are looking at an example 4 in your notes, which is reading a histogram. In the next examples, we're going to talk about how to build a histogram, but I also want to mention to you that on the AP test, I am about 90% sure they're going to have you read one as opposed to making one, because they really care more about your understanding of a histogram and any graph rather than the ability to build one. So I'm just throwing that out there. Okay, so when we look at this histogram, I want you to notice a few things. Make sure you're always reading everything that's happening with the problem. This is a histogram of systolic blood pressure for a group of employees at a small company. So over to the left here we have frequency, and then along the x-axis we have the systolic blood pressure. So I'm going to teach you how to read this and understand it. It's really easy. Histograms aren't horrible. You'll notice they kind of look like bar charts. The only difference is that these are always touching. Like right here, there's no gap ever in a histogram because it's the continuity of the math. So okay, as we go through this, this is a multiple choice question, so I'm just going to talk to you about this. The problem is that the interval that runs from 100 to 110. So that's this one right here, okay? And let's talk about this for a minute. By the way, when we're dealing with the histogram, these are called bins, okay? And if you'll notice, this bin has 7 people in it. So what does that mean, Ms. Griggs? Well, what it means is that there are 7 people in this company who have blood pressure in this range. But let's talk about that range. So go back to our choices here. Let's pick which one is correct. A includes measures of 100 and 110 and everything in between. In other words, is this bin containing people who have blood pressure of 100, everything in between, and 110? Well, I'm going to go ahead and tell you that is not the correct answer. B includes measures of 100 up to but not including 110. Okay, this one actually is the correct answer because it's the nature of a histogram. When you have a bin, you've always got 2 values on the left of the bin and on the right of the bin. The number on the left automatically fits into the bin, but the one on the right goes in the next bin. Okay, so this 80 right here, notice there's nowhere left of that. There's not any bins over there. So 80 goes into this bin, 90 fits in this bin. So what does that mean to you practically speaking? Well, practically speaking, it means that this first bin has all the systolic blood pressures from 80 up to 89. Then 90's in the next bin. So that's how that works. All right, so let's move on to part B. How many employees have a systolic blood pressure of at least 120 but less than 130? So we're looking at, there's 120 and there's 130. So let's see how high that is. That would be 7 people. So 7 employees have that blood pressure. Okay, part C, how many employees are in the sample? Well, that's pretty easy to calculate. We've just got to count how many people are in each bin, and this is a pretty small set, so it shouldn't be too hard. So we've got 2 here, we've got 10 here, that's 12, we got 7 here, so that's 19. And then we've got 2 more, so that's 21. And then we got 7, that's 28. And then 4, that's 32. And then 1 down here, so that would be 33. So there are 33 employees in the sample. Okay, part D, what percentage of employees have a systolic blood pressure below 100? Well, below 100 is going to be this group right here. There are 2 in this bin and 10 in this one. So to get a percentage, that's going to be 12 out of 33 people. And I think it's like approximately like 34%, something like that, 36%, I don't know. So I don't have a calculator with me, so you'll just have to trust me. So that's how you would find the percentage. Part E, describe the shape of the distribution. Okay, so in order to do this, I'm going to erase the stuff I've written here so we can see this better. Okay, when you're talking about the shape, as you can see, there's a big gap right here, and there's a gap right here. So how do we describe the overall shape of the distribution? Well, if I was just going to look overall, I'd say it's probably slightly skewed right, but it's not really that simple. So I'm going to write something like this. The overall shape is right skewed with a significant dip, baby, dip, at 110 and 120, or between 110 and 120. Let's go that. That sounds better. Ah, dang it. Grr, grr. Sorry, kids. I know. Y'all are freaked out. The overall shape is right skewed with a significant dip between, Miss Griggs, use your word, you big goofball, between 110 and 120. That's what I would say. Now, could you say something like it's approximately not symmetric bimodal? You could say something like that, okay? Anything that is obvious is okay. All right, F, estimate the center of the distribution. Okay, well, estimating the center of your distribution, you have to be so careful, because the mathematical center, okay, if you'll look at this, we've got an 80 here and a 160 here. 120 is not the center of the data, because there's more data over here than there is over here. So if you want to truly find the center with a situation like this, we've got a countable number of people. So where the data stacks up is where you're going to call center. So I would say the center of this, let's see, I've got 2 here, 10 here, 7 here, so that's 19. So that's a little over half. So I would venture to say that if I'm estimating this center, I would say the center is at about 108, something like that. And you could probably go 110, 107, anything like that, 105. Those are all pretty good guesses. All right, so we can only see one measure of spread from a histogram. Which measure can we see and give its approximate value? Well, the measure for spread that we can actually see, and we're going to end up talking about 3 measures of spread. You probably realized that as you went through your notes. We have 3 measures of spread: range, standard deviation, and IQR. Well, or interquartile range. Well, the only one we can get from just looking at a graph is going to be the range. So I'm just going to say that I can see that blood pressure ranges between 80 and 160 for this company. Another way you could say it, I would say the range is about 120, because 160 minus 80 is 120, anything like that. All right, part H. If you want to mention an unusual feature, what would you talk about? Is it an outlier for sure, or a possible outlier? Well, anything that lies far apart from the data and leaves a gap is considered an outlier, but we have to be careful. There's a reason the question is worded this way. So if you want to mention an unusual feature, what would you talk about? Well, I would talk about the fact that for this company, there is one individual with a high blood pressure between 150 and 160. Now, what makes it unusual is that it's not following the general pattern of the data. It's out there all alone by itself. So if I had a bin between 140 and 150, it would kind of tie everything in. It wouldn't be that unusual. But because it's out there by itself and there's a gap between it and the rest of the data where there's no data, that is cause for concern. So, is it an outlier? For sure, or a possible outlier? Well, without running the outlier test, which is a specific mathematical way to say for sure this is an outlier or if it's not, we can only say it appears to be or it is a possible outlier. So, this appears. When I say stuff like appears or approximately or about, those are called wiggle words. They're important in statistics. This appears to be an outlier because a gap exists. I'm sorry, my handwriting is so bad. This appears to be an outlier because a gap exists between it and the rest of the data. Beautiful. Explain your reasoning, use good communication. Bam, done. Enjoy.